Now let's continue the previous video here on pre-algebra concepts. So in the last video we discussed about something like x raised to power 2. What we said, it is called as x raised to the power 2. Now I'll just try to run you through a couple of properties. Now this is also called as x as base. This we discussed in previous video, and this as power. And another name for this is exponent. Technically, we are going to use this word a lot, exponent. Now, what are the few properties of exponents? Now, let's say we have a number 2 raised to power 3, and this is getting added with 2 raised to power 4. Now, what this actually means is that 2 is getting multiplied by itself 3 times. It is actually 2, not z. Yeah. And this adds to number which is 2 multiplied by itself 4 times. Now, what is 2 multiplied by itself 2 times is 2 to the 4 to the 8. And then it is 2 to the 4 to the 8 to the 16, and the answer is 24. Now, let's take an example where it is 2 raised to power 3 and it gets multiplied by 2 raised to power 4. Now understand what we have done is that we have changed the operator here. Here it was the operator of addition, here the operator is of multiplication. Now in this scenario, what does it mean is 2 is getting multiplied by itself 3 times, and then it is getting multiplied by another number which is 2 getting multiplied by itself 4 times. Now this will anyway be 8 like we have calculated here, and here it is 2 to the 4 to the 8 to the 16. Pick the same color. Now understand, here it was 8 plus 16. Here it is 8 into 16, which is 6 8s are 48, 4 carry, and 12, 128, right? Now let's do one thing. Is that let's keep to the base same and add the exponents or add the power. Oops. Pick a color. Yeah. Let's keep the base same and add the power 3 plus 4, which will be equal to 2 raised to power 7. Now let's see what we did here. It was 1 1 2 2 2 3 2 4 2 5 2 6 2 7 2. It means this 2 raised to power 1 and what we have written here is the same, that is 2 into 2 into 2 into 2 into 2 into 2 to 2. How many 2's? 1 2 3 4 5 6 7. And the answer, of course, will be same, that is 128. Now what does it mean? Let's erase this. What does it mean is, when we said 2 into raised to power 3 into 2 raised to power 4, when the bases gets multiplied and the bases are same, then the powers will be added. So what we did was 2 into 2 raised to power 3 into 2 raised to power 4. We just wrote it 2 raised to power 3 plus 4. The powers were added and the answer was 2 raised to power 7. When there it was a addition sign here, then we did not do anything with the powers. We calculated this and added the number which we got by solving this 2 raised to power 4. Now let's say we have got a number of, when there is say 2 raised to power minus 1. Now what does it mean? I'll tell you. When the powers are in negative, then they go into the denominator. So let's take an example. Example is 2 into 2 raised to power minus 1. This is 2 into 1 by 2. Answer will be 1. We can also solve it this way. 2 raised to power 1. Anything raised to any number raised to power 1, it remains the same. The number remains the same. Into 2 raised to power minus 1. Right? It is 2 raised to power 1 minus 1. This will become 2 raised to power 0, and anything we raised to power 0 is 1. So whenever you will find the sign of exponent as negative, what will you do is that you will take reciprocal of it. Let's extend it further so that you'll have a little more clarity on this. What we discussed in reciprocals was, reciprocal is nothing but it is product of two numbers which yield number 1, which yield the resultant of which is 1. Now we can also say that reciprocal of 2, let's write it in English also. We can also say reciprocal of 2 is 2 raised to power minus 1. The question arises, how? Thing is that it is the reciprocal of 2 is 1 by 2. The reciprocal of 2 is 1 by 2, and when we multiply with them, the answer is 1. And what we said was that whenever you take the power, whenever you take a number from numerator to denominator, denominator to numerator, the sign of its exponent changes. So this will also can also be written as 2 into 2 raised to power minus 1, and it will become 2 raised to power 1 minus 1, which will be equal to 2 raised to power 0, and the answer will be equal to 1. Now let's take one more small example before we wind up this video. Say we have to solve this as x square into x raised to power minus 1. It will be x raised to power 2 minus 1, which will be equal to x raised to power 1, which will be equal to x. Let's take one more example. Say x raised to power 5 into y raised to power 2 into z divided by z raised to power minus 1 into x raised to power 3. So what we'll do is that we will first bring denominator into numerator and see what action happens on its exponents. it is x raised to power 5 as it is, y raised to power 2, z raised to power 1, so let's write it z only, into, now when we set the number, when we move from denominator to numerator, the sign of its exponent, the sign of exponent, the minus 1 will become 1, so it becomes z raised to power 1, or we could have just written z only, into x raised to power minus 3. Now what we are doing here is we are now taking the terms which have got common basis. So here it is x, here it is x. So this x and x are same, so the bases are, here are same. So let's write one more intermediary step, x raised to power 5, where we'll combine the like bases into x raised to power minus 3. Cool. And then there is only one y, so we write y raised to power 2, and then we have got 2z, so into z into z. Now what we'll do, we will add these exponents, so it becomes x raised to power 5 plus minus 3, so it becomes 5 minus 3, then it is y raised to power 2 as it is, dot or into z raised to power 1 plus 1, which equals to x raised to power 2 into y raised to power 2 into z raised to power 2. So this is how we solve. Where's the question? Yeah, this is the question. Here is this. This is how we solve the question. Now, in why it is important that we know these concepts, because these concepts are going to be extensively used in algebra. Okay, when we are going to study polynomials, when we are going to solve the polynomials, when we are going to define the classify the polynomials in various categories, the exponents, the reciprocals, the concept of multiplication are very important. They will be repeatedly used, and unless you brush up these concepts, you will not be able to understand algebra at all. And these are fairly easy to understand. Should we take one more example? Okay, we'll take one more example. Okay, and we'll stick to the variable part of it. We'll use, a, b, c, or x, y, z, etc. And I'll pause the video, and then I'll encourage you to solve it by yourself. And if in case you're able to solve it, check how I am doing it. And in case you're not able to solve it, then you'll be able to learn that how to solve it. So, let's take it, a raised to power 3 times b raised to power 6 times x raised to power minus 4 divided by a raised to power into b raised to power 4 into x raised to power 4. What is the answer? Now, just pause the video and try to solve it by yourself. Okay, it is, what I said is that we'll take all the terms of denominator into numerator and then apply the properties of exponent. So it is a raised to power 3 into b raised to power 6 into x raised to power minus 4. Now when a moves to numerator, it becomes a raised to power minus 1. When b raised to power 4 moves to numerator, it will become b raised to power minus 4. When x raised to power 4 move to numerator, it becomes x raised to power minus 4. So it becomes into x raised to power minus 4 into x raised to power minus 4. First we have written this x raised to power minus 4, then we have written this x raised to power minus 4. So the answer now will be, or the next step perhaps would be, so we have got, where is this a raised to power? Yeah. So let's combine the like terms with like basis. A raised to power 3 into a raised to power minus 1. So we got only two a's. Then we got how many x's? 1 and 2. Okay, oh, I guess I've written one more x here. Let's move it. So we should have 3 and 3 6 terms. Okay, cool. So it is a raised to power 3 and then a raised to power minus 1. Then we have got two b's, b raised to power 6 and b raised to power minus 4. Then we have got two x's, x raised to power minus 4. It is from here, x raised to power minus 4. And then this is x raised to power minus 4. So what we'll do is that we'll just apply the properties of exponents, which is a raised to power 3 minus 1 into b raised to power 6 minus 4 into x raised to power minus 4 and plus minus 4. Minus 4 plus minus 4 will remain as minus 4 minus 4. So it will be a raised to power 2 into b raised to power 2 into x raised to power minus 8. Now we could have actually solved it without using the properties of exponent also. Typically the way we solve, way we divide. But there the confusion comes. So for example, a3 divided by a will lead a square, b6 divided by b4 will lead to b square. And so the problem is that when you come here, you get stuck and then you get into thinking mode. Okay, so before you get so conversant with how the powers are going to add up or subtract, how the exponents are, and various other properties of exponents, I suggest better it is that you bring all the terms to numerator, change their signs, and then you solve it by applying the properties of exponents. Okay, so here I would have done x raised to power minus 4, so I would have cancelled it here and brought x raised to power x raised to power 4, and then I would have added up, so I would have written a square into b square divided by x raised to power 4, which is equal to a square into b square divided into x raised to power minus 8. So we are done with the basic concepts which are very important when we move to algebra. And now we will move to our concepts of algebra. Thank you.